Okay, so we'll pick up on our discussion from last class. So let me just start with a couple important announcements, or just, just something to take note of. So for the homework set, so the first kind of homework set that you guys have to do for this class, I'll be talking about it and distributing that next class. So as of now, we haven't learned enough for you to kind of start the homework set. So we'll need to kind of get some of the things we learned today and next class under our belt before I can assign the first homework set. But in the meanwhile, hopefully you guys are kind of reading along in the book and doing some of the practice exercises that I designated on the syllabus to kind of help you keep on top of things. But again, I'll give you guys the first homework problem set next class that you guys will have like about a week or so to complete. So not to worry, more information on that next class. Okay, but any questions before we get started right now? Any questions people have? If you're all good, feel free to just throw in all good in the chat. So if you don't have any questions, again, I'm going to be doing this a lot until we get back in person, just because I can't see your faces, so I can't exactly read the room. So I have to just totally base, my pacing and decisions off, what you guys say in the chat, essentially. Okay, so Felix, Jesus, Brianna, Lauren, Kate, I'm seeing a lot of all goods in the chat. So I'll leave us there for now. But if any questions do arise, please feel free to ask me at any point, whether it's about the class or anything we're talking about, etc. Because this is one of those classes that I know is not, it's totally new. Most people have never taken logic before. So it's good to always ask questions. Okay, but I'll go ahead then and share my screen. So let me share that. Okay. I might at one point have to grab my charger for my computer, but it seems okay as of now. But if I do, don't be alarmed. But looking good. So here's the screen. Can everyone see the shared screen? So this whiteboard, there's nothing on it, but can everyone see? Okay, so Pidge says yes, I'm assuming yes. Okay, sweet. So let's start today's class with a brief kind of summary or refresher of what we were learning last class. And then we'll kind of jump into some of the new material. I'm really taking our time here because, again, things are going to get pretty technical pretty quickly. So I want to make sure that we kind of slowly approach that and we're all on the same page before we get there. Okay, so this class again is Introduction to Logic. Last class we we're talking about what makes a good critical thinker, what is a good critical thinker, and we came to the conclusion that good critical thinkers, they only accept claims that are backed by good evidence and argument. And also too, they're the type of person that only provides claims to other people when those claims are justified by good reasons and arguments. Okay, and so that kind of begs the question, because the kind of natural subsequent question to ask yourself is, okay, then what is an argument? So what's an argument in the logical sense, in the more kind of technical way we talked about it last class? What's an argument? What's an argument? So I see Kiana, you put an opinion. So an argument is not just merely an opinion. Oh, Aiden says, sorry, I keep getting kicked out of the meeting and I'm not sure why. Yeah, so Aiden, it could just be like your connection and stuff. That's happened to me before when I've had like spotty Wi-Fi. It's just one of the downfalls of being online and on Zoom. But not to worry, Aiden, this is all being recorded. So you could watch this lecture too at a later time if you're having trouble connecting. Okay, but I'm seeing more people in the chat. A claim backed by evidence, a statement backed by reasoning, a claim backed by evidence. Okay, so this is all good. Now, even more precisely, right? So argument, remember, is a set of sentences. Okay, awesome. Perfect, Kiana. One sentence is a conclusion and the rest are premises. Awesome. So a set of sentences where one sentence is the conclusion and the other or others are either the or premises that serve to support the conclusion. Okay, so a claim, a claim one believes in, typically supported by some sort of truth. Yeah, okay, so more precisely though, what is an argument? It's a set of sentences where one is the conclusion and the other are called premises that serve to support the conclusion. Okay, so now let me just ask you a couple follow-up questions. What is the minimal number of sentences that needs to be in an argument? So what's the very least, so what's the minimal number of sentences that needs to be in an argument? 2, perfect. So as long as you have a conclusion and at least one premise that serves to support the conclusion, then you have an argument. Okay, second question. What is so I just kind of said what the conclusion is. So the conclusion is the thing that's supported by the premises. Now, what's a premise? So what do I mean by premise? So when I say conclusion is supported by a premise, what's another way of understanding that? Okay, so I see Felix, your hand is up.
So if the conclusion, let's say the conclusion is like squids are the best type of sea creature, would a premise be something that that like leads into that conclusion? Like squids have 10 arms, therefore squids are the best sea creature.
Okay, yeah, that's exactly right. So you're right. The premise or premises are going to be reasons that serve to support the conclusion. Yeah, so squids are the best sea creatures is your conclusion. Now, what's the reason why you think that? What's the reason that's provided to support that conclusion? It's that, would you say they have 10 arms or something? And then maybe you'd say an additional thing, and like any creature that has more than 2 arms is just really interesting or something, I don't know. And therefore, squids are the best sea creatures. But that's exactly right. So the premises are just going to provide reasons that support and justify the conclusion. And I'm also seeing in the chat, Jasmine says evidence and Dylan says evidence. That's exactly right as well. So the premises, you can think of them as reasons or evidence that serve to support the conclusion. Perfect. Awesome, guys. So then next we learned about how to write arguments in standard form, right? So suppose I have this argument. So suppose I just have this argument just written like this. Oh, wait, sorry. Writing the argument in standard form would just be doing the following, right? You write each premise on its own line. So all humans are mortal. Professor Cossum is a human. Okay, so each premise is written on its own line. Then you write a line and then the conclusion, right? So all humans are mortal. Professor Cossum is a human. And then, you could think of the line as synonymous with the word therefore. So therefore, Professor Cossum is mortal. Okay, so standard form is just a way of writing out arguments in logic when, again, each premise is listed on its own line, followed by a horizontal line, and below the conclusion. Okay, then we talked about conclusion and premise indicator words. So what were some of the conclusion indicator words? Just maybe name out a couple. So conclusion indicator words. So words that indicate that the conclusion is coming next. Therefore, perfect, awesome. What else? In conclusion, awesome. As a result, perfect. Since. So since actually, Cade, is a premise indicator word. So let's actually move on now. So what are some premise indicator words? So words that indicate a premise is coming. Since is a premise indicator word, right? Because think of the word since. I think cats are the best animals since, I've had pet cats for years and they're always, so sweet and kind to me. I don't know. This argument, my conclusion is I think cats are the best animals. And my premise is what comes after since. Why do I think cats are the best animals? How did I come to that conclusion? Since, cats are really sweet to human beings, or whatever I said. Okay, so perfect. Since is a premise indicator word. Because is a premise indicator word. Good job. Given that is a premise indicator word. Good job. So like for this reason, Felix, yeah, that could work, right? So I believe, X for this reason, and then you state the reason. Given that, good job, due to, so perfect. Okay, so these are all good. So actually, no, wait, Dylan, so is a conclusion indicator word, right? Because when you say so, I don't know. When you're saying so, maybe you'll say like in an argument, all cats, all cats are mammals, all mammals give live birth, so all cats give live birth, right? So is usually a conclusion indicator word. It's like so when you're thinking of the word so is a word that kind of indicates to the reader that you're coming to some conclusion, or that you're wrapping up whatever you're saying. So when you're using the word so in like an essay, for instance, it kind of indicates to the reader, okay, here's the point, right? Here's how I'm wrapping up my point. And given that it serves this function, it's a conclusion indicator word. Okay. Now, the whole point of an argument, remember, is to convince someone of the truth of your conclusion, right? So why do you give arguments? Because you want to convince the other person, let's say, that your conclusion, whatever conclusion you've arrived to, is in fact true. And so therefore, the concept of truth in the first place is extremely important to a class like this. Now, what does it mean for a statement to be true? So what does it mean for a statement to be true? That's another thing we talked about last class. What does it mean for a statement to be true? So a statement is true when what? So I kind of wrote it up on the board last class in a more kind of, in a way that sounded more like technical or like jargony. But most generally, like what does it mean? Yeah, truth preserving. Okay, Nelda, good. So what does it mean for, okay, it corresponds to some facts in the world. Perfect. So what does it mean for a statement to be true? A statement is true when it corresponds to a fact in the world. Another way of saying this is maybe like the statement matches reality, right? So what does it mean for a statement to be true? When that statement just matches reality, when it matches how things really are. So it's another way of kind of saying what it means for a statement to be true. It's not false. Now, yes, what it means for a statement to be true, of course, is, it cannot be false. But more specifically, like in what way can it not be false? It cannot be false in this very specific way. It's not false because it matches reality, right? So that's, or, it corresponds to a fact, right? So remember, therefore, right, truth is kind of this relationship between a statement and reality. And that should make sense, right? So when you do say something is true, you think to yourself, oh, because that's how the world really is. And when you say something is false, you think to yourself, because that's not how the world really is. So I tell you, the earth is spherical in shape. That statement is true because it matches what the world is really like, right? How the planet Earth is really shaped. You look at these satellite photos and you see that it's a sphere. And when I tell you the Earth is flat, you know that that's false because it does not match reality, right? When you take photos of the Earth, it does not look square, right? It looks spherical. Okay, awesome. And then finally, what is a belief? So that was the last thing we discussed. So what's a belief? Belief. Okay, so Dylan, not exactly though, because you want to make sure that your definition of belief doesn't utilize the word belief. So something you personally believe to be true. Okay, Paige, good. So something that you think is true. So you don't want to utilize the word belief when you're defining it, right? Because then that would be a circular definition, right? It wouldn't be a definition that's exactly illuminating, because imagine if you just really did not know what the word belief meant and you read the definition and you saw that same word in the definition, you would be confused. Okay, but what Pitch says, I think, is exactly right. So something you think is true. In other words, when a person takes a statement to be true, that's when they believe in that thing, right? So Jalen says something you put faith in without consulting facts. No, Jalen, that's not exactly right either, because you could believe something where you do in fact consult the facts, right? So I believe that the earth is spherical. That's a belief that I have, not just based on no reason, but based on, you know, certain photos I've seen of the earth being spherical in shape. Or I believe that Sir Francis Bacon was one of the key people who instigated the scientific revolution. Okay, I don't believe that based on no reasons. I believe that based on, you know, detailed historical knowledge that I have, right? So belief is just, it's not only about faith. No, you're right. You could, you know, there are people who believe in things without consulting the facts, right? So people who believe in, I don't know, QAnon conspiracy theories, or people who believe in you know, a whole host of things. So people who believe that the earth is flat, you know, these people are obviously not consulting the facts. But not, you know, people don't always do that, in other words, right? Usually if you're, you know, good at reasoning and you're a good thinker, a good critical thinker, that you're going to believe only in the things that correspond to the facts. Aiden says something that is personally held as true without necessarily having evidence or facts to support it. Yeah, so I think that phrasing maybe is a little bit better, Aiden, because you're saying you don't necessarily have evidence for it. So there are people who believe things that they don't have evidence for, but there are a whole host of people, like probably us in this class, that do believe things because of the evidence we have for that thing, right? I believe some cats have fur because I have a cat with fur. Exactly, Pitch. So that's a great example. Okay, awesome. Now the main thing we kind of talked about, so I'm just going to pause my video for a second while I grab my charger, my computer charger. But the main thing we talked about last class too, in relationship to truth and belief, was just the following: that truth, when it's, you know, when it comes to a statement can only have one truth value, meaning that the statement can only either be true or be false, right? You can't have a statement that's both true and false at the same time. Now, when it comes to belief, right, people can believe a whole host of different things, right? And so, you know, belief, there's like, you can have a diversity of belief amongst different people, but even though people could believe a whole host of different things, right? Those things that they believe, only one of them can be true, right? So if I believe the earth is spherical and my friend believes the earth is flat, only one of us can have the correct belief, right? We can't, oh, sorry, my cat. We can't both have those two inconsistent beliefs at the same time, and for those two beliefs to be true at the same time. So even though people can believe a whole host of contradictory things, all right, that things that contradict one another, only a certain set of those beliefs can in fact be true. Okay, so give me 1 second. I'm just going to pause. Okay, and now I'm back. Just had to grab my computer charger, but my cats were kind of clawing at me. They're always a little sad when I'm closing the door and away from them, but it's at least I'm home, you know, with them, so they can't complain too much. Okay, cool. So that kind of is just review from last class. Now for today's class, I want to just start by going over various types of sentences to kind of get clear to you guys that there only are a certain set of sentences that we're concerned with in this class. And that there, although there are a whole host of different types of sentences in language, we're only going to consider a certain subset of sentences. Okay, so what are the different types of sentences? Now, the first thing to note is an asatoric sentence. Okay, so what's an asatoric sentence? An asatoric sentence is a sentence that is either true or false, or a sentence that can have a truth value, in other words. Okay, so asatoric sentences are the only sentences that we're concerned with in this class. Because in this class, since it's logic, we're interested in arguments that establish, right, or help support true claims versus not, right? And you'll see in just a second why some of these other types of sentences are not the types of things we're analyzing in this class. Okay, so what might be some examples of asatoric sentences? So a sentence that can be evaluated as true or false, a sentence that we can look at and we can think to ourselves, okay, that's false. Or we could look at, we can think to ourselves, that's true. Or we could look at and think to ourselves, okay, I don't know whether it's true or false, but I know in principle, I can determine whether that sentence is true or false. What might be some examples of these types of sentences? Any thoughts? Okay, humans are a type of fish. Perfect, Pidge. That's an asatoric sentence because we look at that and it's clearly false. And even if we didn't know, so suppose I didn't know anything about human beings or fish or what have you, even if I didn't know that, I can at least determine that that's an asatoric sentence because I can think to myself, okay, that's the type of sentence that I can in principle determine as either true or false. Okay, other examples? So good job. Humans are a type of fish. What else? It's asatoric. What else? Other examples? The world is round. Perfect. Good job. That's an asatoric sentence. I'm 7 feet tall. Asatoric sentence. Again, how do I figure that out? By noticing that's the type of sentence I can determine as true or false. My PFP is green and white. Yeah, okay, that's an asatoric sentence. Perfect. So yes, any of these. I'm wearing glasses. That's an asatoric sentence. Okay, now again, we're only interested in asatoric sentences in this class because these are the only types of sentences that can have a truth value, right? Notice the word assert, right, in the word asatoric. They assert something is or is not the case. Now again, there's a whole host of asatoric sentences that we know in principle has a truth value, but we as human beings have not discovered the truth value yet. So here are some examples of such asatoric sentences. So again, I'm just want to make this point clear because asatoric sentences, it has nothing to do with whether we actually have discovered whether that sentence is true or false. It's just that in principle, right, we can figure out, that sentence as either true and false. Or another way of putting that, is in principle, irregardless of what human beings know, this is the type of thing that is either true or false. So quantum particles collapse after being in a superposition. We don't know the status of this asatoric sentence, right? The jury is still out on this, right? So if any of you who study physics, you would agree with me here. Now, even though we don't know whether the statement is true or false, whether the sentence is true or false, it's still an asatoric sentence, right? Because it's still a sentence that, irregardless of what we know, has a truth value. Whether it's true or false, we just don't know yet. Aliens are in outer space. That's another example of an asatoric sentence, right? Because again, it asserts something. Now, we don't know whether there are aliens out there. Some people think they are, some people think they aren't. There's really good arguments, at least according to me, there's really good arguments on both sides. And so, therefore, we don't really know the answer to whether there are aliens, but nevertheless, this is an asatoric sentence because it's the type of sentence we can assign a truth value to. Okay, so in other words, having a truth value is different, right, than knowing what the truth value is, right? So both of these sentences have a truth value. We just don't know what that is. but insofar as they have some truth value, irregardless of what us finite human beings know, that's what makes it an asatoric sentence. So it's like a kind of a small point, but it's something, that's very important. So I just wanted to make that really clear. Now, the next time a sentence is interrogative sentences. Okay, so now let me put that up on the board. Interrogative sentences are questions, essentially. So they're any sentence that ends with a question mark. Now, the way to kind of remember this is look at the word interrogative and notice that interrogate is the root here, right? Interrogate is the root for interrogative. And to interrogate someone is just to ask someone critical questions, right? So now let me ask you, or actually, let me just say, interrogative sentences, these sentences that ask questions, they don't have truth values. So unlike asatoric sentences, these are not the types of sentences that have truth values. Because notice they ask questions, and questions are not the type of thing that you say are true or false. So let me just now ask you, what might be some examples of an interrogative sentence? What might be an example of this? So example of an interrogative sentence. I just gave an example. So what might be an example of an interrogative sentence that asks a question? So that was an example of one. Is the world round? Okay, good, Dylan. Perfect, Jalen. Did you pour the cereal? Awesome. What time is it? How fast can you run? Is online class engaging? Ooh, that hits kind of close to home, huh, Felix? Yeah, so these are all really good examples. Now, notice that none of these sentences are the types of things that you can evaluate as true or false. Yeah, all interrogative sentences are just questions, right? They're just questions. And notice questions are not the type of thing that you can evaluate as true or false, right? So look, what day is it? Right? So it'd be very bizarre for someone to say, what day is it? Right? To ask that question. And for me to say, true, that's true. That would make no sense, right? So what day is it? How could that sentence be true? It doesn't make sense for you to claim that sentence is true because the question, what day is it? Any question does not assert some matter of fact. So it's not the type of thing we could evaluate as true or false. Compare that to an asatoric sentence. Today is Monday. Okay, we can actually evaluate that as true or false because that today is Monday is actually making a claim about the world. Whereas what day is it is a sentence that's making no claim whatsoever. Okay, so of course, interrogative sentences are fundamentally important to life and to communicate. But in logic, we don't really care too much about interrogative sentences because again, in logic, we're only considering the types of sentences that could be utilized to justify a conclusion. And so any sentence that states a question, of course, it cannot be used as evidence or justification for a conclusion. So we're not really going to, minus this lecture, we're not going to think too much about interrogative sentences. Okay, so moving right along, the next type of sentence are imperatives. So imperatives are just synonymous with commands, right? So here are some examples. Write this down, take out the trash, sit down, go for a walk. Okay, so now let me ask you, for imperative sentences, are these the types of sentences that we can evaluate as true or false? So do they have this similar quality to asatoric sentences, or are they more similar to interrogative sentences? Okay, so perfect, Dylan, no. So imperatives are not the types of sentences that we can evaluate as true or false. And for that reason, they're more similar to interrogative sentences, right, than asatoric ones. Because what would it mean to say that these are true or false? So write this down. If I said, okay, if someone told me write this down and I said, that's true, what would that mean? It doesn't make sense. Or if someone said, take out the trash, and I said, that's false. I mean, you would have to think that I'm just kind of thinking and talking informally or misunderstood what the person said, right? So if someone said, take out the trash, and I said, that's false, maybe informally what that would mean is like, I'm not going to take out the trash. But notice that it's not operating in the same way when we say something is false in relation to an assertoric sentence, right? Sit down, that's true. What would that mean? Or go for a walk, that's false. See, so notice these are not the types of sentences that we can evaluate as true or false because they're merely just commands, right? They're not making assertions. None of these sentences can be deemed true or false. Instead, they serve a different function in language, right? So these sentences are not trying to establish that something is the case or that something is not the case. Instead, these types of sentences are just used to direct people's behaviors and actions, right? And therefore, imperatives are also not utilized in logic and they're not utilized in arguments. But of course, it's just important to say what they are. Now, the last type of sentence is an exclamation. Now, an exclamation is just a momentary expression of a feeling or attitude. Okay, so I don't know, what might be some examples of these? So, you're at the concert and, the artist leaves stage early and you say, boo, right? That's an exclamation because you're showing an attitude of disapproval. Or you're at the Australian Open and you notice that Nadal is coming back from being down 2 sets and you say, yay, right? That shows a momentary attitude of approval. Okay, so exclamations are just going to express some type of feeling or attitude. And again, therefore, they're not the types of things that can be evaluated as true or false, and therefore are not the types of sentences that we're going to be considering and utilizing in logic. Okay, now here are some just practice questions. So maybe let's look over this together a little bit. So from the book. Now, let me first ask. Does this sentence have a truth value? So in other words, is this the type of sentence that we can evaluate as true or false? So first question. Okay, yes, perfect. So what kind of sentence is this? Given that you guys answered yes to the first question, what kind of sentence is this? Assertoric, perfect, Ashley. Awesome. Okay, and now let me ask you finally, what truth value does this sentence have? What truth value does this sentence have? False. Okay, perfect. Awesome. Good job, guys. Next sentence. Turn in your homework. Okay, so first, does this sentence have a truth value? Awesome. Okay, what kind of sentence is this then? Awesome, imperative, good job. Okay. Does this sentence have a truth value? At 3 p.m. Eastern Time on January 15th in the year 1134 AD, there was a snowstorm in Manhattan. Okay, so does this sentence have a truth value? Okay, now, therefore, what kind of sentence is this? Assertoric, perfect. And what is the truth value of this sentence? No clue, perfect, the end. So we have no idea. I have no idea, you guys have no idea, we just don't know. Now notice, just because we don't know what the truth value is, does not imply that the sentence does not have a truth value. It does, right? It is, either it did rain, or sorry, either there was a snowstorm on that particular day and time in Manhattan, or there wasn't. But this is probably just something we'll never know, right? But just because we're never going to know it does not imply that this sentence doesn't have a truth value. So it's kind of what, this is something I kind of like about logic, is it makes very clear that truth is distinct from what we know, right? So oftentimes, like, you kind of I don't know, at least this is how I used to think. It's very easy to kind of muddle up the concept of truth with the concept of like knowledge. So what we know. So you only think, okay, true things are only the things that we know. But no. That's not what truth is in logic. Truth is totally distinct from what we do in fact know. Truth just has to do, again, with the correspondence between a sentence and reality. So even though we'll never know whether this is in fact true or false, this sentence does have a truth value. We just have no clue what that is. Okay, here's another example. Okay, so again, this is esoteric because the sentence has a truth value. But now let me ask, do we know what the truth value of the sentence is? No, of course not. So we can't predict the future with complete certainty. So we don't know whether the next president will be a Republican or Democrat. We just don't know. However, even though we don't know because the sentence pertains to some future event, this sentence does have a truth value, right? So in a couple years, we'll figure out the answer, we'll figure out what that truth value is. But right now, in 2022, we don't know, right? We just don't know the truth value of the sentence. Okay, awesome. Nice. So we've gotten down under our belt really important concepts concerning different types of sentences. Now, the next thing I want to just discuss, so we've been talking about truth as it relates to particular sentences corresponding to reality. Now, I want to talk about a different notion of truth called logical truth. So logical truth and logical falsehood. Now, a logically true sentence is going to be a certain type of sentence. A logically true sentence is a sentence that is essentially always true, and it's just not possible for that sentence to be false. So it's impossible for the sentence to be false. So let me put this up on the board. A logically true sentence is a sentence. So a sentence, is logically true, just in case. It's not possible. It's not even possible for the sentence to be false, okay? It couldn't be false in any possible scenario, right? So in other words, a logically true sentence is a type of sentence that if you doubted the truth of that sentence, like it wouldn't really make sense, right? Okay, now I'm gonna put these definitions up on the board and then we're gonna work through examples. So, not to worry if this isn't entirely clear just yet, because I think examples always make the concept clear. Now, what is a logically false sentence? A logically false sentence is a sentence that cannot possibly be true. So it's the opposite of logically true, right? It's a sentence that it wouldn't make sense for you to claim that that sentence is true. It couldn't be true even in theory, right? So again, logically true and logically false have nothing to do with the real world. It doesn't, it has nothing really to do with whether, that statement corresponds to some fact. Instead, it has to do with the structure of the sentence itself. So a logically true sentence, given its structure or given what it pertains to, is always going to be true no matter what. And a logically false sentence, given its structure and given what it pertains to, will always be false no matter what. Okay. And then finally, the middle ground between these two extremes is what we call logically indeterminate. Okay, so what's a logically indeterminate sentence? It's a sentence that is neither logically true nor logically false. Okay, so what does that mean? It's a sentence that could be false if the world was different, right? So its truth or falsity is entirely contingent on how the world is. Okay, so now let's go through, I'm going to actually break it down logically indeterminate a little bit more, and then we'll work our way to the other two. So again, logically indeterminate. This category of statements or sentences is the biggest, and it's the easiest to come up with examples of, because most sentences are logically indeterminate, which just means that their sentences or their statements of fact or falsehood, but their truth value is totally dependent on the features of the world. So in other words, what the world is like determines whether such sentences are true or false. So they could have been true or false if the world was differently, right? If things went differently, right? And in that sense, they're totally dependent on the world. So here's an example of a logically indeterminate sentence. Professor K is wearing glasses. Okay, so now why is this sentence, so we know the sentence is true, I am wearing glasses right now. Now, why is this sentence logically indeterminate and not logically true? So why does this sentence fall under the category of logically indeterminate? It's kind of a tricky question. Exactly. Okay, good job, Pidge, because I could take off my glasses, right? So in other words, the sentence Professor K is wearing glasses was just dependent on how the world was. I don't know, certain decisions I made this morning to wear my glasses. It was also dependent on the fact that actually I did get LASIK, so I should not be wearing glasses. But unfortunately, I'm that small percentage of people where my eyes will continue to get worse throughout my lifetime. And so LASIK didn't help me, right? So that's another way the world is that makes it such that I have to wear glasses. Now, the world could have been totally different. I could have gotten LASIK and I could have just been totally fine and never had to wear glasses again, such that I wouldn't be wearing glasses to teach this lecture. Or I could have just decided to take them off like I just did, which Paige directed me to, right? So notice that this sentence is logically indeterminate because although it's true, we could think of how easily it could have been false given different circumstances, right? I could have been wearing contacts instead. I know, doesn't that kind of suck? I was like, spend all this money to get LASIK, I saved up for it, but then my eyes are just going to keep getting worse. So it is what it is. But yeah, I could have decided to wear my contacts, Felix. That's another way. Okay, now what might be some more examples of logically indeterminate sentences? Let's start with that. What might be some more examples of this? So I just gave one. Professor K is wearing glasses. What else? So notice I'm wearing glasses is not a matter of logic, right? I could have decided not to wear them today. So it's clear to see that although that sentence is true, it could have quite easily been made false, right? If the world was just slightly different. Okay, now more examples. I had cereal. Good job, Felix. Okay. Now, I actually don't know if that's true or false, right? So Felix had cereal. That could be true, right? Or it could be false. And then it's not, okay, cool. So I had cereal. So I'll put Felix actually to make that even more clear. So Felix had cereal. That's a false statement. Now, notice it's logically indeterminate in the sense that although it's false, if things were just a little bit different in Felix's life, I don't know, she had this cereal she needed to, or sorry, they had the cereal they needed to use up, and they, were in a rush. So suppose, Felix, that you were in a rush, then he would instead have not had cereal, right? So, or he would have instead had cereal. So it could have been totally different. But if I wanted cereal in another universe, exactly, right? Birds are extinct. Birds are extinct. Okay, good, Pidge. So this is another logically indeterminate sentence, right? Because, well, in this case, it's false, right? But we could imagine living in a world where birds went extinct, right? Good job. So good job, Felix and Pidge. Awesome. I'm wearing a hat right now. That's logically indeterminate. You're in logic class, logically indeterminate, right? So I'm wearing a hat right now. That's false, but it could have been true if I made a different decision this morning. You are in logic class is true, but it could have been false if things went differently as well. Okay, now let's contrast these types of sentences with logically true sentences. Okay, so this is a little trickier, but what might be an example of a sentence that's logically true? So it's a type of sentence that's true, and it's not possible. It's not possible for that sentence to be false. It's just if that sentence was false, the sentence would no longer make sense. Okay, so I'm glad that we're seeing, you guys are saying this. So Kiana says the earth is round. Now, let's think about that. You're right. The earth is round, Kiana. That is a true sentence. But if that sentence was false, or let me put it like this, is it possible for that sentence to be false? Now, I know this requires a little thinking outside the box, but is it possible for the sentence, the earth is round, to be false? And the answer is yes, right? Because we could have lived in a totally different universe where, I don't know, the earth had a different shape, or I don't know, we didn't even live on the planet Earth in the first place, or what have you, right? So the earth is round, although it's true of us in our world, in our universe. We could imagine that sentence or statement to be false. And so as long as you can imagine and under different circumstances or in a different scenario or in a different world, right, that sentence being false, then that sentence is logically indeterminate. Same with the sky is blue, Elizabeth. So the sky is blue is also logically indeterminate, because we can imagine if human beings were a little bit different, I don't know, our rods and cones were a little different and we had different color perception, or if, you know, the chemical properties of how light reflected was slightly different, then the sky would no longer be blue, right? So that sentence is also logically indeterminate. Now, Pidge, oranges are oranges. That's good. So that's an example of a logically true sentence, because you cannot possibly think of a way for the sentence to be false, right? So any identity sentence is logically true, because to think of such a sentence as false would just not make any sense. So what would you mean by oranges are not oranges? That kind of starts to break the rules of logic. Opinions are personal. So good, Rigoberto, or Rigo, you go by Rigo. Good, Rigo. So how do we define what an opinion is? Opinions are, you know, one way of defining it is they're, you know, statements that concern one's personal outlook on something. And so if that's the definition of an opinion, then yeah, that's a logically true statement, right? So any identity statement, again, is going to be a logically true statement. Space is infinite. So Kiana, no, that's not logically true, because again, this is a statement that concerns just how our universe is, right? So we can imagine, so first of all, space is infinite. I guess I would have to know a little bit more about what you mean by that. But you know, we can imagine a universe such that's, you know, well, our universe where space has some finite properties, right? So that would not be an example of a logically true sentence. Pages, water is partly hydrogen. Okay, so water is H2O. That would be an example of a logically true sentence, because again, that's an identity statement, right? So what is the definition of water? Well, the definition of water just is H2O. And one is a number. Good, Esmeree, yeah, so that would be an example as well. Okay, so these are all good. Here are some other examples. So again, not to worry, I know that this is kind of tricky. So, but hopefully now as we're like working through the examples, it starts to become more clear to you guys. So 2 + 2 = 4. That's a logically true sentence, because notice it's an identity statement, first of all. So what is the meaning of this numeral 4? It's just the addition of 2 and 2. Also, notice any kind of mathematical fact is going to be a logically true sentence, because it's not the type of thing that you can doubt, right? So if you know, or it's not the type of thing that could possibly be false, right? So what would it mean for 2 + 2 = 4 to be false? That just makes no sense, right? And what would it mean for a square has 4 equal sides to be false? That would make no sense, right? Because the definition of what a square is a shape with 4 equal sides. What would it mean for water is H2O to be false? It's not possible, because that's just what the definition of water is. So notice these are all identity statements, meaning that they're just statements kind of stating what a particular thing is, right? So what is 4? It's just the addition of 2 and 2. What is a square? It's a shape with 4 equal sides. And what is water? It's just H2O. And given that there are identity statements, they're not the types of things that you could possibly consider false. They're not the types of things that can possibly be false. Okay, now on the other hand, what might be some examples of logically false statements? Logically false. So again, they're not the types of statements or sentences that can possibly be true. It couldn't even be true in theory. So it couldn't even be true in theory. So aliens exist? No, that would not be an example of logically false. Okay. Okay, good. Blue is red, Pidge, says Pidge. 1 is a letter, says Felix. And 2 + 2 = 5, says Elizabeth. A square is round. Okay, so this is all good, right? Good job, guys. So you guys are definitely getting it down. So notice these are all examples. Yeah, so Felix, you would think like 1 is a numeral, right? Instead of a letter. Yeah, so that works. Okay, so these are all examples of logically false sentences because, again, they're not the types of sentences that could possibly be true given their structure, right? So let me now just break down some of what you guys said. So 1 is a letter. That's logically false because the number 1 is a numeral. So part of how we define this number 1 is by claiming that it's a numeral and not a letter, right? Blue is red. So blue is a distinct color from red, right? So we can't imagine a world where these two colors are the same, right? 2 + 2 = 5. That's logically false, right? Because what is the kind of meaning of or understanding of the numeral 5? Well, it's not the addition of 2 and 2, right? So this would be a logically false identity statement, right? A square is round. Also, that's a great example, right? Because how do we come to define what a square is? A square is a type of shape with 4 equal sides, and therefore it's not round. So this would state kind of a contradictory definition of a square. And so that's also logically false. So this is all really good. Here are some other examples. So it can't even be true in theory. A triangle has 2 sides. That cannot even be true in theory because part of the way we define what a triangle is a shape with 3 sides. Dogs are not mammals. That cannot be true even in theory, right? Because part of how we define what a dog is a mammal. It's the type of creature that gives live birth, warm-blooded, etc., etc. 2 + 2 = 5. Also logically false, right? Because how do we define the numeral 5? Well, it's not by the aggregate of 2 and 2. It's the aggregate of like 2 and 3, right? A square is round, not how we define what a square is. Okay, so logically false sentences are the types of things that cannot possibly be true because they violate some kind of condition in how we define a particular concept. Now notice that the truth value, so for logically true sentences, and logically false sentences. Their truth value has nothing to do with the way the world really is, right? So determining 2 + 2 = 4 is logically true. We don't have to go out and observe the world and notice that that's the case. No, it's just something that we arrive at via pure logic, via how we define the numeral 4 and how we define addition, for instance, right? Such that we know that 4 is the aggregate of 2 and 2. A square has 4 equal sides. We don't have to go out and observe the world to figure this out. We just know, given the way we define what a square is, right? It's the type of shape with 4 equal sides. Same with water is H2O. So you may think that this is somehow contingent on the way the world really is. But if you think about it, how it just has to do with how we define water. So once you realize that we define water by means of just 2 hydrogen molecules and an oxygen molecule, well, then you come to the conclusion that once we have this definition, that's just what water is. So this cannot be this cannot possibly be false, because if water was not H2O, we'd be talking about a totally different concept, not water. And same with logically false sentences. So logically false sentences, again, are not at all dependent on the way the world really is. A triangle has 2 equal sides. We know that that's logically false, independent of the world, right? It's just false because of the way we define what a triangle is. Dogs are not mammals. We know that that's false, again, given the way we define the definition of a dog. 2 + 2 = 5, again, false, given the way we define what the numeral 5 means and what the aggregate of 2 and 2 is. And these are very distinct from the logically indeterminate sentences, right? Because whether Felix had cereal or whether I'm wearing glasses has nothing to do with how we define anything. All it has to do with is looking out into the world and noticing, okay, is Professor K wearing glasses right now or not? Did Felix have cereal this morning or not? Right? You have to actually observe or maybe ask us to figure out the truth of those claims. And so therefore they're logically indeterminate because they concern the real world and what the real world is actually like. Okay, so hopefully that's clear. Now more examples. So actually let me, okay, yeah, so just more examples of maybe logically indeterminate. The earth is flat, you're sitting, it's raining, I'm your professor, right? So those are all logically indeterminate because their truth value is contingent on the way the world is. Okay, now just a couple things to talk about before, we have 15 more minutes, so I just want to say a couple more things. So a little bit more about different types of arguments. So far in this class, we've defined just what an argument is most generally, right? So argument is a set of sentences where one is the conclusion and the premises are kind of reasons that serve to support the conclusion. Now, in logic, there's two types of arguments. There's deductive arguments, so arguments that utilize deduction, and there's inductive arguments. So arguments that utilize this different thing called induction. And when we're making, when we're utilizing deduction and we're making deductive arguments, we strive first and foremost for our arguments to be deductively valid. So a deductively valid argument, we always want to be making arguments, that are deductively valid. And so this kind of begs the question, what is a deductively valid argument? Okay, so a deductively valid argument, I'm going to put this up on the board, is an argument where it's not possible, okay, for all the premises to be true and the conclusion at the same time to be false. Another way of putting this definition is just the following. If all the premises in that argument are true, the conclusion must also be true. Okay, so this concept of deductively valid argument is extremely important. It might be the most important concept in this class because we're going to constantly be referring back to it because, again, it's kind of the litmus test for determining whether this is a good argument, right? So you always want your argument to be deductively valid. If the argument is not deductively valid, well, you're kind of just throwing around a bunch of junk because essentially what you're doing is you're providing an argument where there's no relationship between the premises and the conclusion. And of course, therefore, that's not a good argument because you always want the premises to be the types of things that serve to support the conclusion, such that if those premises are true, the conclusion would just have to be. Now, oftentimes in logic, you don't know for certain. You don't really know whether your premises are true or false. But all deductively valid is telling us is that if those premises were true, if they're true, the conclusion would have to be, irregardless of whether we know for certain whether those premises are true, okay? So this is a very important point and it's kind of nuanced, but I'll kind of keep drilling it into you guys. Now, here are just two premises in an argument. So let me just put this up on the board. So all fish can swim. So these premises happen to actually be true. But again, they don't, for an argument to be deductively valid, the premises don't in fact have to be true. But in this case, they are. So all fish can swim. And second premise, trout is a fish. Now, let me just ask you guys, what conclusion can we deduce from these two premises?
Therefore, trouts can swim.
Yeah. Okay. So given the truth of the premises, we've established a true conclusion. So this argument is deductively valid, right? So in other words, again, if you're asking yourself whether the argument is deductively valid, what you ask yourself is, if the premises are true, could the conclusion possibly be false? Now, let me ask you guys, if these premises are true, could this conclusion possibly be false?
I just thought of one.
Of one
Like-
what?
Like one where the premises are true, but the conclusion could be false.
Okay, so that would be an example of what? Let me first ask you first and foremost.
It would be an
That'd be-
invalid argument.
Exactly. That would be an example of an invalid argument. So if you have an argument where the premises are true and the conclusion is false, it does not meet the criteria of this definition. And so therefore that argument is not deductively valid. Another way we say that in logic is the argument is invalid. So what's your example?
It's like based off of the trout thing. It's like some fish can walk. The trout is a fish, therefore some trouts can walk.
So some fish can walk. A trout is a fish. Therefore, what's your conclusion?
Some trouts can walk.
Okay, so I'm glad you brought this up. So some fish can walk, trout is the type of fish, therefore some trouts can walk. Okay. So why is this argument invalid?
Because from what we know about trouts, they can't walk.
No, so this one's actually a little bit tricky. So,
Is it
oh,
because
someone
the
else
statement-
talking?
Yeah, it's me, Dylan. Is it because the statement "some fish can walk" does not ensure that that's statement will have any effect on the statement of trout is a fish? Because
Exactly.
some fish does not mean, oh, any type of fish at random. It means some type of fish. Because of the vagueness of the sentence, it doesn't fully apply to it.
Exactly. Okay, so I'm going to do a contrast between two arguments to make this point crystal clear, okay? So now, so sorry, who brought up this, raised this example? Because I didn't get to see your name,
Felix did.
unfortunately. Huh?
Felix did.
Oh, awesome, Felix. Thank you, Felix. Yeah, so Felix, you brought up a good example of an invalid argument. Now it's invalid because, this is the reason why, just because some fish can walk does not imply that trout can walk, right? Because some fish can walk, it can, it can refer to, let's say, all these different type of fish, disincluding trout. Now, again, when you're trying to determine whether an argument is valid or not, what you're thinking to yourself is just this: if these two premises were true, would this conclusion have to be true? So although, Felix, this is a good example of an invalid argument, the one issue is the reason why you stated it's invalid was not exactly right, because it doesn't really actually have to do with the truth value of this first premise. We all know that this first premise is false. But again, you can have a valid argument that has a premise that's false, but it's still valid because if the premises were true, the conclusion would have to be true. Now here, I'm going to make this clear because the second argument, now actually, let me first ask you, is this second argument valid or invalid? All fish can walk, trout is a fish, therefore all trouts can walk. It's valid. Okay, so this first argument is invalid. This second argument is valid. When we're thinking about validity, we're only thinking about the structure of the argument, okay? We're not actually considering whether the premises are true or false. All we're thinking to ourselves is the following: if these premises were true, would the conclusion have to be true? Or in other words, right, is it the case that it's not possible for these premises to be true and the conclusion false. Now for this first argument, if we assume these premises are true, the conclusion does not have to follow. And here's why. So I'm going to draw a Venn diagram to make this totally clear. Some fish can walk. So this circle represents the category of all things that can walk, okay? So I'm just going to write things that can walk. Now we're in there, right? Human beings are in there, dogs are in there, cats are in there, et cetera, et cetera. Now what this argument is saying is fish, there's some fish, right? Let's say, I don't know, that are in this category of things that can walk. Now I know that strictly speaking, that's a false statement. But again, when we're determining the validity of the argument, we're just going to assume that the premises are true. So there are some fish that fall into this category of things that can walk, right? So I'm going to just put, some fish. Now, some fish can walk. It's not saying all fish can walk. So what that implies is that there are some fish that stand outside of this category of things that can walk, right? So some fish can and some fish can't. Now, the second piece of information we have is the following. A trout is a fish, okay? Based on that, do we know for certain that some trouts can walk? Yes or no? Based on the fact that some fish can walk and based on the fact that a trout is a fish, do we know for certain that some trouts can walk? Good job, guys. The answer is no, right? Because a trout can be this type of fish that cannot walk, that sits outside of this category of things that can walk. And so this argument is invalid because the truth of the premises does not guarantee the truth of this conclusion. Now, let's compare this argument to this argument below. All fish can walk. Now, notice again, we know for sure that that's false, right? But when you're considering the validity of argument, you're only considering its structure, such that is this the type of argument where if these premises were true, the conclusion would have to be true. So let's just assume that these premises are true to see if the conclusion would have to follow. Okay, all fish can walk. Okay, so this is the set of things represented by this big circle, right? So things that can walk. Oops, sorry. And it says all fish can walk. So where am I going to draw the circle that represents fish for this second argument? All fish can walk. So where's the circle that represents fish? Where is it going to be drawn? So for some fish that can walk, I drew the Venn diagram circle. So it partly overlaps things that can walk and partly doesn't. And so Dylan says in the other circle entirely, Aiden says inside the larger circle. Good job. So if all fish can walk, I'm going to represent the Venn diagram such that the circle that represents fish sits inside the circle that represents things that can walk. Because again, every single fish, according to this argument, can walk. Okay, so this, sorry, so let me actually put it like this. So this circle represents fish. Now, we know that trout is a certain type of fish. So where am I going to draw the circle that represents trout? Oh, okay, good pitch. I'm glad. See, some people are visual learners, some people are not. So, I like to throw in the Venn diagrams for the people who are more visual. If you're not, a visual person, and if this is confusing, no worries, just focus on the argument itself. It's just what works for you. Yeah, so in the fish circle. Okay, yeah, Felix says, love me some fish diagrams. Nice. Yeah, so trout is a type of fish. So the circle representing trout is going to sit inside the fish circle, right? Because what that means is every trout is a fish, right? So every trout is going to sit in the fish circle. Now, given the truth of these two premises, all fish can walk. So all fish are in the larger things that can walk circle, and all trout are fish, or another way of saying that is trout is a type of fish. So all trout are going to sit inside of the larger fish circle. Given the truth of those two premises, we're assuming those premises are true, would the conclusion have to follow that all trout can walk? Now look at this diagram and think to yourself, based on this diagram, does it follow that all trout can walk? Again, given that we're just assuming these two premises are true. Correct, Felix. Dylan, is Murray. Okay, good. The answer is yes, right? So if we assume all fish can walk, and if we assume that a trout is a fish, then we just have to come to the conclusion that all trout can walk. And for this reason, the second argument is valid, okay? So this is what you need to remember about validity. Validity concerns the structure of the argument, okay? Now we all know that fish can't walk. So strictly speaking, we all know that this first premise is false, but that doesn't matter to us, right? Because validity only concerns the relationship between the premises and the conclusion, such that if these premises were true, the conclusion would just have to follow. Some fish can walk though, but all fish can walk is false, right, Aiden? Right? So strictly speaking, that's false. Okay. So let me just say one last thing. Now, the concept of validity, it may be a little bit like, you may be thinking the following, like, okay, but if we're making a good argument, right, don't we want our premises and don't we want our premises to actually be true, right? Don't we want our, so yeah, you can make this argument, all fish can walk, trout is a fish, therefore all trouts can walk. But usually in argumentation, we're concerned with, an argument that has true premises. Yeah, Professor Costin, this is a valid argument because it has the right structure, such that if the premises were true, the conclusion would have to be true. But I'm really concerned with arguments that have true premises, because that is usually like a good argument. And if you're thinking of that, you're now thinking of the concept of soundness. So let me just state that, and then we're going to pick up on here next class. Oh, Dylan, sorry, is your hand up?
Yeah. I just had a quick question. What if you changed the argument to all fish can walk, some trouts are a fish, therefore some trouts can walk? Would that be
So, wait, all fish can walk.
all fish can walk, some trouts are a fish, some trouts can walk? Would that be logically that be a valid argument, or
That would be a valid argument. Yeah. So all fish can walk. Some trout are a fish, therefore some trout can walk. Now, of course, we know that that second premise is false because all trout are fish, right? Not only some, but it's valid because it has the right structure, such that if those premises were true, if it was true, that's only some, whatever, would you say only some trout can walk? Or sorry, only some trout are a fish?
yeah, some trout,
Yeah, so
like
if that were,
because I was
yeah, if
thinking
that were
like with the
true,
first example, it's the first, like, I already forgot the word for it. The first statement is some fish can walk, and because that one is only some, then it becomes invalid. But if you made it so all this and then some this or this, I'll know how to
yeah,
map this out in my head to make it up. Yeah.
yeah, okay, so the first one is invalid because again, when you're determining whether something's valid or not, again, you're considering the structure. So let me actually just say one last thing. So I think this is going to help you, and we'll pick up on this next class. And, as we keep talking about it and practicing this will be really clear. But I just want to contrast the definition of validity to soundness. And I think that that will help you guys kind of like see what's going on here. Now, a sound argument, okay, is an argument that's deductively valid, okay, but it also has true premises. So usually when you're making arguments, you're trying to make sound arguments, right? Because you want your premises to be in fact true. So a sound argument is like the pinnacle of a good argument, right? Because it has the right structure and it also has premises that are true. Okay, so now to kind of, let me just get back to your question, Dylan. When you're considering whether an argument is valid or not, you're not really focused on the truth value of the premises. In other words, you just assume the premises are true to see that if those premises are true, would the conclusion naturally follow, right? In other words, a sound argument is going to be the type of argument where you're never going to have, an argument where it's not possible for the premises to be true and the conclusion false, right? So it has that type of structure. Whereas, so that's a valid argument. And a sound argument is an argument that's valid and also has true premises. So again, when you're thinking of these examples of just a strictly valid argument, a valid argument that's not sound, you're going to think of examples where you have these premises, right? You don't really know whether the premises are true or false. You assume that the premises are true. And when you assume that the premises are true, the conclusion would just have to follow, right? So that's when you think of validity. Soundness is when we actually notice that the premises are in fact true. So I think that this distinction can kind of help you now with like your examples. But I know that we're out of time, guys, so I'm going to stop here. Next class, we're just going to pick up on this discussion of valid arguments, sound arguments, and then we'll move on to inductive arguments. So I'm just going to briefly say a couple things about those because those won't really matter too much to us in this class. But anyways, guys, we're out of time, so I'm going to let you go. If you have any questions, feel free to ask me. I also have office hours right after this. But okay, guys, I'll see you guys next class.
Thank you, Professor.
Thank you, Professor.
Thank
Yeah,
you.
no problem. Thank you, guys.
Thank you.
So Bennett, you had a question. Hello, sorry, I just got joined right now. We've been working to get back, but yeah, so all of these lectures will be recorded, so no problem, Bennett.
Thank you so much. I'm sorry. It literally just got online right now.
Oh yeah, no worries. Yeah, I understand that happens. So everything is recorded. Thanks, Tatiana. And yeah, no worries at all. So you'll have the recording of this lecture to refer to.
Okay. Thank you so much. Have a great day.
You too.